Okay, so welcome to the Python workshop. So if you don't know already, it's held by the Computer Science Club. So there's QR codes to our events page and the Duck Lounge. Hopefully you already know where it is. Firstly, in the Ghana acknowledgement, we acknowledge and pay our respects to the Ghana people, the traditional custodians whose ancestral lands we gather on. We acknowledge the deep feelings of attachment and relationship of the Ghana people to country, and we respect and value the past, present, and ongoing connection to the land and cultural beliefs. So firstly, just some quick links. So the first one's the link to the slides, so you can follow along, as well as a link to a repo with all the code for it, so you can follow along with that. I'll just leave that up for a few seconds so you can enter that in.
Yep, this afternoon should be here. This is like, sorry, there's more proper traffic, isn't it? Yeah, don't.
Oh, I've already signed up. I've just.
Oh, yeah. The traffic is crazy coming in on North Terrace. It wasn't even moving. I thought, God, I'm back in Australia. Sorry about that. Sorry, I have to put this on the phone. Like that Mac is on the way home. She's got a job or something.
That's fine. If I can just show the sticker.
Oh, then that way she just shows
Yeah.
it. Oh, that's back on your phone. It's like an ID to jump in that they know that you're a member. Yes, you have to make turn the number off and put the cover down. Then it's so there we go. That's a mummy thing. Anywhere, wherever you guys can see it. So you just scan it next time. Or you just show the sticker. Oh, you show it. There you go. And that way you won't lose it either, maybe.
Just have a just getting started. So if you have a laptop,
You should go down.
you can follow on the slides and the code as well.
Maybe talk to some. I'll be back in a sec. I'll put my stuff down with you.
So hopefully you have had enough time to open those links up. So we'll continue with the content. So just starting off, what is Python? So Python is basically a high-level interpreted programming language, and it's mainly famous and well known for its readable syntax, mainly because the code looks like plain English. And it has a different AI and machine learning workflows, as well as data science, automation, web dev, and cybersecurity. So like basically anyone can use it, and it's quite popular. So some people might ask, isn't Python slow? So Python itself is slower than languages like C++ and Java, since those languages are interpreted, not compiled. But the performance critical libraries like NumPy, Pandas, TensorFlow, and PyTorch, so mainly those that are used for AI, are actually written in C or C++. So basically, developers get the ease of using Python to write actual code for their program, while taking the advantage of the speed of C++ from the use of these libraries. And there's a bunch of different implementations for Python. So the default one is CPython, which basically converts your code to bytecode, which is basically kind of similar to like machine code. It's like in a step between. There's also Cython, which compiles to C, Jython, which runs on the Java virtual machine, and also PyPy, which is just-in-time compilation. So you can see that image there is a bit older now, but basically the default one isn't that fast, but as long as you're using those libraries that are made in C, C++, you can get that speed benefit. So getting set up. So there's a few different ways to install Python. The main default one is to download it from python.org and then follow those steps. So typically you can use a binary, so you can download a binary link from the Python website, or you can use a package manager like apt for Linux or brew for macOS or Choco for Windows. And then you can verify that it's installed by using Python and version. And make sure when you install it, especially for the GUI installers, make sure you keep the path set correctly, so the Python and pip are accessible from the command line. However, this is not the recommended way, mainly because of virtual environments, which we'll talk about in a bit. So before that, we'll talk about pip. So pip is basically Python's package installer. So it allows the installation of third-party libraries from the Python package index, or PyPy. And there's a bunch of different common command examples. So there's pip install, uninstall, list, show, install, most of the common ones. And it also supports a requirements file for reproducing what requirements you need for a project. And this follows a format of package name, equals, and version number. And you can also do greater equals symbol. So you can install the version that's newer as well. And then in order to use this file, you can do pip install -r requirements or txt. So I mentioned before that Python binary is not the actual recommended way. So another way is using Conda, which is a package and environment manager. And so you can either install Anaconda, which is a full package set, or Miniconda, which is more lightweight, easier to set up. And it comes with the Python install, as well as a package manager and environment tools. However, this is still not recommended, at least anymore. In the past, like a few years ago, it used to be like the default and recommended way, but now there's better alternatives that you can use. That's way faster and more easier to use. So the best recommended way is to use a project called UV, and it's basically a fast Python runtime and project manager written in Rust. And if you don't know what Rust is, it's basically a really fast language that's type safe and memory safe. So it's basically lightweight, cross-platform, and has isolated environments for UV. And there's also some other alternatives like Poetry, but you can see in that graph there, it's not as fast as UV. So in order to install it, it's way easier than the other installation methods. You can just do that command for macOS or Linux, or the other PowerShell one for Windows. And then similar to the typical Python and pip setup, these are slightly different commands for UV. You can initialize a project, by using UV init and then the project name you want. And then if you want to install dependencies, instead of doing pip install, you do UV install. And then you can run scripts using UV run and then the script name. That just makes sure it actually runs the script inside the virtual environment rather than the global Python instance you have installed. So specific to UV is this pyproject.toml and Python version files. So it's similar to requirements.txt, but for UV. So it has some aspects of this package.json file, which is typically used for like JavaScript, Node.js installations. So it has things like name, version, description. It also specifies a minimum Python version. And this, the pyproject.toml file is used by other package managers like Poetry. But this Python version is more specific to UV, and it specifies the exact Python version that you need to install. And basically, all you have to do to get started, once you install UV, you just have to run UV sync. That basically handles installing all the dependencies listed in this file, as well as setting up your virtual environment. So you can just do that in one command rather than like several without UV. So I mentioned this thing called virtual environment. So why exactly do we need this? So basically, we want to avoid dependency conflicts between projects. So for example, here you can see that image. You may need to use older versions of libraries. For example, you can use a project that relies on Python 2.7, and then the specific matplotlib version that you need. And it has some breaking changes. You either don't want to spend time to fix it, or there's some feature that doesn't exist anymore in the new version. So that's why we have virtual environments, so you can set that up, and you can have different Python versions as well as dependencies and package versions for each project. And like I mentioned, you just have to use UV sync to basically activate the virtual environment and install all the dependencies required. And compared to Conda, the virtual environment is stored in the current folder. So that's the actual working project folder rather than like a global instance. So it's more isolated, and you can see exactly what the virtual environment the project is using. So like I mentioned before, you may need like different Python versions. Another reason is if you want to support legacy code, especially like in work, you may need to support a different code base that hasn't been updated yet. You may want to try to explore different library support versions if you're making your own package, and also doing some other testings across versions to make sure it works. So if you want to specify a particular Python version in UV, you can do UV init project name, and then do the Python flag with 3.9 is for the Python 3.9 version. So it's really simple to set up, and then you can do UV sync to make the virtual environment and install the dependencies. If you have an existing project with UV installed already, you can edit the pyproject.toml file as well as the Python version file and just edit those files. You can see in this one, it has Python 3.12. You just have to replace that with whatever version you want and then run UV sync again. And then it'll just set up your virtual environment with a selected Python version. Now, Jupyter Notebooks is basically an interactive coding environment that's used commonly for Python, and it's really useful for data analysis, visualization, and teaching. The main benefit of this is you can run code in these blocks, and it actually saves progress in the code file. So if you want to share, like for example, an AI model you trained, it saves all that state, so you don't have to run the whole process of training the model again. So in order to launch the Jupyter Notebook from the UV environment, if you have a project set up already, you just have to add the package, so add UV add Jupyter, and then you start the Jupyter Notebook by doing UV1 Jupyter Notebook. An alternative to doing this is using the Google Colab, which is basically just a website version that's hosted, and that basically does the same thing, so you don't have to set everything up locally. And the main benefit of these notebooks is it supports Markdown, so you can have all those headings, all the text, as well as the code in one place, as well as the output as well. So that's really useful. So if you do it locally, after you run that command from the previous slide, you should open a new browser window to select the IPYNB file, which is just a file name for that, the Jupyter Notebooks. And then you can select that file, and it has something like this. So if you download the code with Git, and then you open it up in VS Code, and then run that command, it should open. It's open on my laptop, but it should open a browser tab automatically. Basically, there's that list of the files in your current working directory. So for example, we can go to this file, and you can see there's some examples for this workshop. So the main things of this, I'll just make it bigger so you can see easier. Of course, there's like a save icon. You can add new cells like this. You can add Markdown. So if you can do a title, and then you have to change the type here, so you can either select code, Markdown, or raw. And then if you want to render it, you just press the play icon. Same thing for the code. If you want to run the code instead, do the same thing with the play icon, and then it shows the output there. And there's also some other typical commands like the copy and paste. You can stop this. There's the restart, fast forward. Like I mentioned before, you can run the selected cell. There's some other options there. And there's also one for running all the cells in the notebook. And there's also one for if there's any issues and it just crashes for some reason, you might have to restart the kernel, which is just like the Jupyter Notebook server, basically. So you may have to do that if something goes wrong. So moving on to some more Python basics. So first of all, comments is pretty useful in any programming language. Obviously, they're used to explain code and make it easier to read, especially for other developers. So you can start, for Python, you have the hashtag for single line comments. And then you can have something like hashtag print hello world as a comment. You can also have multi-line comments. So they typically use multiple hashtag lines or triple quotes with the triple speech marks or those. And it basically can be used as doc strings, which is kind of different from comments because doc strings are typically used for documentation. For example, you may have one for like a function and you have it inside a function in the doc string. So it's mainly for more general documentation for other developers rather than single inline comments that you may use with the hashtag. And printing, you can use the print command, which is quite easy to remember, and it's used to display output to the console or notebook cell. And it can print anything from like strings, numbers, variables, or expressions. And by default, Python automatically adds a new line at the end. But if you want to change this behavior, you can use the n equals the speech marks with no space to change this. And also supports multiple values with commas. So for example, you can see here in the third section of the code, and there's a bit with my name is and the name. So my name is basically a string, and then the name is the variable, which is Doug. So you can do that with Python. Another thing is you can use f-strings. So f-strings is basically for more cleaner formatting. In this line below it, you can see it's the similar thing but with the age. So you can see here in this example, it has the round function, which basically has it takes the age, which is right now Python interprets that as a float, I think, and it rounds it up to integer. So instead of having the decimal point, it just has an integer. So you can do things like that with f-strings, which is really convenient. Inputs, so if you want to read user input from the keyboard, you can use the also easily named input function, and it always returns a string, so that's something you have to consider. So you must convert for like numbers to like integer or float if you need to make that, if you need that types in those in your logic. So the typical syntax is like the variable name equals the input and the prompt message, and then the input can be stored and reused later. So for example here, if you run this cell, it prompts you for entering your name, and then you can enter your name and it says hello Doc, and then you can enter the age as well as the height, and then it prints all those things that you entered at the end. And again, you can see here it's using the f-string as well to substitute the variables. So it's substituting the name, age, and height combined with like this normal string text. So variables and data types. So in Python, the variables are dynamically typed, which means Python basically it assumes what type you're using. So there's no actual like type enforcement. However, you can actually do a thing called type hints. So basically, that's more so for the developer. So you can add types like int, float, string, list, dictionary, all the common like types for programming languages. But basically, Python, if you try to like modify the logic to like print a decimal where it's meant to be integer, it doesn't actually automatically fix that for you. So it just runs the code without passing the type. But another thing is you can do multiple assignment. So for example, you can see, not in this one, but you can do like A, comma B, comma B, comma C is equal to 1, 2, 3. So you can do that as well in Python. You can also do type conversion with like the int, float, and string. So you just have to do like this, say if an int and then the variable or like the string, and it converts it for you. And you can also check the type of variables with the type function. So you just have to put the variable or like the input inside those brackets, and then you can print it to see what type it is. So now some maths. There's a bunch of operators. Of course, there's the basic operators like addition, subtraction, multiplication, division, and there's also like floor division, which gives you an integer result, as well as the modular, which gives you the remainder, and the exponential, so you can get like 10 to the power of 10. So it works with numbers, variables, and expressions. If you go back here, you can see here you just use the print commands again, and then you just can run the actual operators inside that brackets. That's quite simple. So control flow, so there's a bunch of you can have if and else statements, And in Python, you use indentation rather than like curly brackets to define where the functions are. So basically, if you want to have an if statement, you have an if, and then like the condition, and then you have a colon, and then you indent the code that's running next. And then similar thing, if you have an else if or elif in Python, it allows like multiple condition branches. So if the first condition is not true, you can do the second one with a similar structuring. There's also for loops. So Python is really simple. That's why it's like quite close to English. It's really good for like similar to pseudocode, I guess. So you can do for food and food items, and then you just print the food. You don't have to worry about iterators like in C++. Similar thing with while. You have the while and then the condition, and then the colon, and then all the code underneath that. And there's also break and continue. So break basically exits the loop completely when it reaches that condition. And then continue just skips running that code after it. So it basically skips the rest of the loop. So for this example, it skips the rest of the loop when the count is 2, and the break exits the loop when the count is 4. And you can just easily use the operators here. If you see this equals equals, it's basically just checking if x is equal to 0. So a single equals is assigning a value. Double equals is basically checking that value. Functions, so functions are basically a way to make reusable blocks of code, and it's defined with the def keyword. And it can take parameters and return values. So for example, here you can take the arguments a and b, and then just return the sum of that. And then you can simply call it by doing like print, and then add to the function name with those arguments. And it can take the parameters and return values, and then basically just helps keep code organized and modular. So if you go back here, run the code, so you can see the first 3 bits run successfully. So the first 2 make sense. It adds 3 and 5, yes, and then 4 and 6 adds 24. Then here, like I mentioned before about the type-ins, it doesn't actually enforce it. So if you go here, try to multiply 4.12 and 6.3, which are not integers, and even though in the function it says it's an integer, it still returns like a float. So it doesn't actually enforce it. So if you want to enforce a type, you need like another if statement. So for example, you have this. It just checks if that instance is of that type for both A and B. And then if it isn't, it just returns an error. So you can see that's what's happening here. Since we're multiplying those 2 which aren't integers, it's giving that type error. So imports and libraries. So import basically lets you use external modules and libraries. And modules are just basically different like files of Python code that other developers have made and they can take advantage of. So they can either be standard, or you can write your own modules inside your code base. And it just basically makes your code more modular and easier to use. And libraries extend a Python with extra functionalities. So there's 3 main ways to import modules. So you can import module, which is basically importing all the code, all the functions in that entire module. You can import module as alias, so you can shorten that name. So if it's some module with a long name, you can just call it like df or instead of data frame. For example here, you can import numpy as np, so it's just easier to use it in your code. And you can also import specific functions. So for example here, you can have from random import randint, which just gives you a random integer. So that just allows you to import specific things rather than importing the whole library. And it's typically good practice to have most of these imports at the top of the file, mainly so everything's like loaded at the start. If you're using the Jupyter Notebook, especially on the Google Colab, you need to use this syntax, so exclamation mark pip install numpy to install the package before you actually import it and use it. Some of the packages, for example, like mat, like default Python ones, so you don't have to install them. They're just included in the Python by default. So there's some tasks in the other Jupyter Notebook. So you can have a look. If you go back to the home page, there's a Jupyter Notebook called tasks. There's a bunch of different ones here. So you can give you like 5 minutes, I think, to have a look at them and try to write some code for that. Most of these, if you need hints, you can have a look at the examples. If you're really stuck, there are answers you can have a look at, but do try attempting it by yourself first. Hopefully you had time to try some of those tasks. So quickly, if you want to have a look at the solutions, and so the first one is just writing names Alice, put age, use the F strings. You can do age times 12, we're just calculating the months. Task 2, if you know the BMI formula, some of you might have to look it up, but if you put that in, put some random thing, you can use the BMI as weight divided by height squared, and then it prints that to 2 decimal places using that 0.2f. Task 3 is basically creating a dictionary, so you can use this format, so the curly braces, name, with a colon and then the actual name, and then similar thing for the other ones. And then you can use the sum function with the length of the how many students there are to get the average, and then you can print that. Here is just using a bunch of different operators, and it just shows you all those different options. Control flow, you can just use another for loop with an if statement. So it just loops for all the numbers in there, and then you have an if statement checks if it's negative. If it's negative, it just skips them by using continue. Otherwise, it prints them, and that's when it's n is greater than 10, it breaks, so it exits the loop. And function is basically just a factorial. So if you check if it's less than or equal to 1, it returns 1. Otherwise, it returns. It calls the function recursively, so it does n times factorial n minus 1. And if you print factorial 5, it gives you 120. So back to the slides. So like I mentioned earlier, Python can be used for multiple things. So one of the main uses of Python is for AI and data science. So the main reason is it has a bunch of key libraries like NumPy and Pandas for data handling, Matplotlib and Seaborn for visualizing like graphs, scikit-learn for machine learning, and TensorFlow and PyTorch for deep learning. So there's a bunch of common applications like predictive analytics, natural language processing, training like AI models, and computer vision. So NumPy is just numbers Python, and it's basically just optimized for arrays and matrices, and it's way faster than using the default Python list. The main reason for this is it's written in C and C++, so you get that performance of those languages in the Python syntax. So you can just provide powerful math and statistical functions. So you can see here it just creates an array. You can see that alias again. It makes an array of 1 to 5. And then it has a bunch of print statements with array mean and squared, and it makes a 2D array. So it has those square brackets with a comma. You can see it prints a matrix, so you use the /n for a new line, and then the matrix variable, and then you can print a transpose as well. In NumPy, you can just do matrix .t, so you can easily do that in just like 2 characters. So Pandas is another really useful library. So it works with data frames, which are basically tables, and series, which are columns. So it's great for like trying to clean the data if you have a data set with lots of invalid data, or like something that's not ideal for running like a model on. It's good for filtering as well and summarizing, and it has a really easy integration with like CSV files, Excel, and SQL. For example, here you can see it's importing pandas, and then it has the data frame creation, and then you can display the data frame. So you can do df.describe, and it basically gives you that summary. If you just do the df, it gives you that data frame we created initially with the data, and then you can do things like filtering the rows. So you can do, like in this line, you can just see if the column age is greater than 21, and then it returns the matching columns, or matching rows, sorry. And then if you want to save this CSV file, you can just do df.to CSV, and then the name. Index false basically just avoids writing all those column numbers basically. And then if you want to read it, you do a similar thing, just read CSV and then file name. And then you can print that information as well. Matplotlib is another really useful library, and it's quite popular for its features of plotting and making charts really easily. And it works with NumPy and Pandas data as well. So in this example, you can see the data make 2 arrays. So you can have a plot So you just have to create a new plot. So this one is just a plot of square numbers. So you can add things like title, labels for the X and Y. You can enable the grid, and then last one is the show, which just shows the actual graph. And you can also like configure the marker and the colors and the line styles as well. So Python can also be used for cybersecurity as well. It's mainly used for AI, but there's also benefits in cyber domains as well. Although most people, if they're using Python for cybersecurity, wouldn't use it in the Jupyter Notebook. They typically just run it on the device normally. So it's used quite a lot in security research, pen testing, and automation. So some of the key areas are like hashing and encryption, trying to like make secure data, doing networking and packet analysis. If you're trying to like capture particular information from a device and try to figure out what it says, as well as doing web requests and API testing. So there's some libraries like Hashlib, cryptography, Scapy requests. So the first one is Hashlib, which basically provides different hashing functions. So some common algorithms are like MD5, SHA-1, SHA-256. So basically hashing is just a one-way transformation that's not really reversible. So the main uses of this hashing is for like password storage and verification, as well as like file integrity checks. So for example, if you download a file from the internet, most of the time there'll be like a checksum, like an internet checksum. So you can download that and then run that command to check if that hash matches. And then if it matches, it basically means there's no corruption or tampering with it. If it doesn't match, that something is invalid or corrupted. So in Python, you can just import a hashlib. You have to use the encode to make sure it's converted properly. You can just use like hashlib.sha256, and then you can put a password variable in, and then you can print it, and then it prints like a hash like this. And then, for example, if you want to simulate some stored hashes, for example, probably do this in the like a database. So you can have 2 users here, and then you can have a function here just checks if the hashes match. And this is basically used for like password checking. So it doesn't check the plain text, it checks the hash of it. So it checks it for Alice and Bob, and since Alice and the password here matches, it returns true. Another good library is cryptography, and this basically provides encryption and decryption, both symmetric and asymmetric. So that's basically just to do with different keys. So it supports various different encryption algorithms, and it's mainly used for like secure message storage, API key on config protection. So for example, here it's using the Fernet, which is just like a really easy to use symmetric encryption. Typically it's not used in the real world, but for this example you can see it just generates a key which it needs for the encryption, and then you can just encrypt and decrypt a message using the encrypt and decrypt functions. So you have to use the B, which converts the message to bytes first to make sure it's converted properly, and then it just prints the encrypted and decrypted messages here. And there's other bunch of more secure algorithms like AES. You can probably research them. You can still do all those in this library. And there's also the request library, which is basically a simple library for HTTP and HTTPS requests. So basically just a web browser request. So it's quite commonly used for trying to scrape the web. So if you want to scrape a database, but if it's like blocked, you can use this. You can also test different APIs or like target devices during pen testing to see like what ports are open. You can also automate logins and forms or brute force like logins. For example, here it's just sends a GET request, which is just fetching data, sends it to this link, and it has a response. And the response is in the JSON format. So you just pass it like that. In this case, it removes the origin field since that contains your IP address. Basically, it just prints the status code. So if it's 200, it's basically just okay, everything went good. And then it prints the response in JSON. For example, here you can see a bunch of headers, like a user agent is the Python request library. And you can also do a post request in this library as well. So you can just do that with like a username. So you can have like an argument here and then an actual value. Similar thing, you can just use a post function and then attach the data to it. And then similar thing, you can print that as well. Scapy, so it's used for packet crafting and sniffing, and it supports like custom network protocols as well. So it's more commonly used for like network traffic analysis and penetration testing tools. So the main issue with this is it doesn't run in the Jupyter Notebook due to requiring admin privileges. If you still want to run it, you can do sudo Jupyter Notebook allow root, and that just basically overrides that, and then it should work properly. Otherwise, you can just run it in a normal Python file on like VS Code. So for example, here it just pings Cloudflare DNS, it just pings it, and then it prints the results. So it sends 1 packet and then got 5 packets in response. So there's just some additional resources that you might find useful. So of course, documentation for Python is there. Has all those technical like functions and quite technical. There's a bunch of other resources like Geek for Geeks, which is more like lesson based. It's more easier to follow. There's also Kaggle-Learn, which is more for AI and data science focus. FreeCodeCamp is always a pretty good resource. There's also Awesome Python, which is basically a list of useful Python libraries. So there's a bunch more. We only covered a few today, but there's a bunch more that you can look at and play with. And just briefly, the open source team. So I'm one of the open source and infrastructure manager for the Computer Science Club. Open source is basically just software where anyone can inspect, modify, and enhance it, and it just promotes collaboration and transparency. And it's basically free to use, so it just promotes a better culture of innovation and community-driven development. And if you want to learn more about the Computer Science Club open source team, we currently work on a bunch of different open source projects. For example, like the CS Club website, Discord bot, as well as like a timetable website, and also a voxel game engine. And we have a bunch of more exciting projects planned ahead. So there's links to our website and GitHub page there. And if you want to join, we're always on the lookout for new people to join. We do have a recruitment process, so it's mainly just filling in a Google form, having a short technical assessment, and then doing a short interview. Just mainly to know you have some technical skills they can contribute to the code. So if you want to join, you can scan that QR code there. And that's it for the workshop. So if you have any feedback on our event, you can scan that QR code there. I believe the food is ready here. Huh? Yeah. Yeah, so they have burgers, so please only take 1 burger per person, and then with some chips as well.
Wait, what the fuck are you walking, huh?